My dear students, Assalamu alaikum. In our last lecture, we studied about the graph of trigonometric functions, in which graph of sine, cosine, and tangent we discussed in our last lecture. Today, we will study further those graphs in which period of sine, cosine, and tangent, then amplitude of sine and cosine, and the vertical translation. First of all, for that, we need to draw here the graph of sine and cosine. Graph of sine was like this, and graph of cosine was starting from 1 was like this. This was y is equal to sine x, and this is y is equal to cos x. This is x-axis, this is y-axis here, this is x-axis, this is y-axis. Our today's topic is period of trigonometric function. First of all, we will discuss about period of sine and cos. What is the period of sine and cos? Here is sine x and cos x. What is the period of sine and cos? The sine and cosine functions are called periodic function because they repeat themselves over and over again. As here you can see, sine is starting from here and it's going up to this point. After that, again the same curve is there as here, starting from x-axis. Again the same curve here with a different color I'm showing, with the same curve. This is the repetition. Okay, it means up to here is the one complete round. This is the period. This revolution is completing from 0 to 360 degree. Okay, and from 360 to 720 is the second round. Here in cosine, this graph from here to here is same. After that, it's repeating itself. This one is again with the same shape. Okay, and this also from here to here, this repeating after 360 again. Up to here will be this 720 degree. The period of a periodic function is defined as the length of one repetition or cycle. Length of one repetition or cycle. As here this length of one repetition is of 360, then the basic sine and cosine function repeats every 360 degree, and period of sine x and cos x is 360 degree, or if it is in radian then will be 2 pi radian. 360 degree or 2 pi radian. Then after that, period of tan x. Yesterday we discussed about the graph of the tangent x, trigonometric ratios of the graph of the tangent. That was like this. Then was like this here, and here like this. this is same shape, then this is the again same shape, okay, and this is again same. Tangent functions behave very different to the sine and cosine function. The tangent function repeats its cycle after every 180 degree. If this one round we are taking, one round can be from this position to this position, okay, and this, you know, at 90 is infinity, then here at 270 is minus infinity. From 90 to 270 are here from minus 90 to 90, this is minus 90, okay. This will be, this is the this period is of 180 degree. From 92 to 70 is also 180 degree. From minus 90 to plus 90 is also 180 degree. Then period of 10x is equal to 180 degree or pi radian. 180 degree or pi radian. Then after that, we will discuss about different graphs. Y is equal to a sine bx plus c, y is equal to a cos bx plus c, y is equal to a tan bx plus c. In that, we need to discuss about the amplitude. Then the next thing is the amplitude of trigonometric function. Amplitude of trigonometric function. The amplitude of a periodic function is defined as a distance between maximum or minimum point and the principal axis. Maximum and minimum point and the principal axis. It is like this. As this is graph of sine x, then this x-axis is the principal axis. This x-axis is the principal axis. Okay, this is the principal axis. This one, this one. Then this point is the maximum point and this point is the minimum point. From principal axis to maximum point, this length, or from principal axis to minimum point, this length. This is the amplitude. From principal axis to maximum point, or from principal axis to minimum point, that is the from principal axis to maximum or minimum point. That length is amplitude. That length is amplitude. Then after that, we will discuss about some different type of trigonometric functions. Suppose we are having here y is equal to a sine bx plus c. A sine bx plus c. A sine bx plus c. Then what is a here, what is b, and what is c here? What are these constants? This a affects amplitude. Affects amplitude. Suppose here is only sine x, then A will be 1. Okay, the amplitude is 1. If here is 2 sine x, then amplitude will be 2. If here is 3 sine x, then amplitude will be 3. Then after that, this B affects the period. This B affects the period. Okay, here I'm giving you the example for amplitude. Suppose here is 2 sine x. Okay, then here amplitude is 2. Amplitude here we are presenting with A. Okay, in the general y is equal to a sine bx plus c. Okay, A is the amplitude, that is 2. Suppose here is 3 sine, in angle here is 3x plus 2 or something else is there, but this in the beginning this 3 is the amplitude. Here A will be 3. Now here sine bx, this B affects on the period. Is in the beginning of today's lecture we discussed about period of trigonometric functions. Period of the trigonometric function. First of all, we are writing here the period of sine. Period of sine x, I told you, that is 2 pi radian or 360 degree. 360 degree we can write here. Okay. Then how this B will make this period change? If here is sine of 2x, function is sine of 2x, then period of this function will be 360. If sine x, then 360, then sine 2x, then will be 360 divided by 2. And here period of sine x is 360, then period of sine bx, that will be 360 divided by b. If any constant is multiplying there with the angle, that constant we have to divide on the period of sine x. Okay, in this way we can find the period. Okay, then after that, this C, what is C? C is the vertical translation. This C is vertical translation. How it will be? Suppose here is function is y is equal to sine x plus 3. C is 3 here. Then usually for sine the principal axis we are taking this x-axis. Then principal axis will start at 3. Vertically we will go up 3. Then principal axis will be at 3. This will be the principal axis. Then sine will be like this and curve will be along this axis. Curve will be along this axis. This is the vertical translation. Now after that, we'll discuss for cos. Y is equal to a cos bx plus c. A cos bx plus c. In cos also this a affects the amplitude. Affects the amplitude in same way as it is working in sin x. Suppose there is 3 cos x, then amplitude here will be 3. Y is equal to 3 cos x, amplitude will be 3 here. Then after that, this b, how b will work? B affects on period, affects on period of the function. Suppose there is cos bx, function is y is equal to cos bx. You know, period of, then what will be the period here? Period of cos x is also 360, but cos bx will be 360 divided by b. What constant is multiplying there with the angle? That constant we have to divide on this period 360. Or if it is in radian, then it will be at the place of 362 pi, 2 pi divided by b. This is the way. And this c here also represents the vertical translation. Vertical translation. How vertical translation? You know, for cos, the graph of cos is like this. Graph of cos is like this. Suppose here we are taking y is equal to cos x plus 1. It means here vertical translation means c here is 1, at the place of c is 1. Then this principal axis we will go at y1. Okay, vertically 1 we will go, and we will draw this principal axis at y is equal to 1. Then this will be the principal axis. Then this we will take the principal axis, and graph will be according to this axis. Graph will be according to this axis. Then after that, y is equal to a tan bx plus c. Y is equal to a tan bx plus c. Here in tan, this a does not represents the amplitude. Okay. You know, in sine and cosine, there is graph is like wave. If no wave will be there, okay, no that type of curve will be there, no wave will be there, then amplitude will not be there. Amplitude is of for the wavelength. Okay, as stretches of the graph, there is no amplitude for the tangent. Okay, to the stretches of the graph, there is no amplitude, mean curve is not coming in the graph of y is equal to tan x. Here is no amplitude. Then this a or any other constant, just we will take as simple constant as 2, 3, 4, like that. No amplitude. Then after that, what b represents? B will work as it is working in sine and cosine. Okay, affects the period. Affects the period. You know, period. What will be the period of tan bx plus c? Its period will be, you know, period of tan x. Before that, I told you tan is repeating itself. Graph of tan x is repeating itself after every 180 degree. Okay, then period of tan x is 180, but this b as in sine and cosine, we were dividing this constant, and here also we will divide. Then period of tan x here is 180 divided by b. If function here we are taking y is equal to tan 2x, then period will be tan 180 divided by 2. Okay, and after that, this c represents the vertical translation as it is in sine and cosine. Vertical translation. This c represents the vertical translation. Now I will show you all these things on graphing software. You can see on this graphing software First of all, here, this is general form, mean the basic function of sin x, y is equal to sin x. This is the basic function. If here in the beginning, this is amplitude at the place of a, you know, that is the amplitude. If here amplitude we are taking here 2, then you can see this amplitude 2, then this height is increasing more. Before that it was 1. This red color, that is the basic function of sin x. Okay, basic graph of sin x. Then after that, the green one is when we are taking amplitude 2. Now you can see this from principal axis to the maximum point, that distance is 2. Or from principal axis to the minimum point, that distance is also 2. This is the period. After that, sorry, this is the amplitude. This is the amplitude. This from principal axis to the maximum point or principal axis to minimum point, as we have taken here amplitude 2, this one. Then after that, you know, this bx, b represent effects on the period. Suppose here we are taking period, at the place of b we are taking 2. It means here is 2, it means sin 2x. If sin 2x will be there, then what will be the period here? I'm explaining you this thing. If sin 2x is there, then what will be the period of sin 2x? Period of sin 2x will be equal to, sin x has period 360, then this constant 2 is multiplying, we have to divide here. 360 divided by 2 is 180. Then the new graph will repeat itself after every 180 degree. As period is coming here 180, then that will repeat itself after every 180 degree. Yes, you can see here this sine is coming from here to here, and after 180 is repeating itself. After 180 it's repeating itself. From 0 to 180 is the same shape. Again from 180 to 360 is again the same shape as it is from 0 to 180. After that, the vertical translation, this d at the end, the constant that is adding, that is the vertical translation. Suppose here I'm taking vertical translation 1, this one. Okay, now you can see here 1, this curve is rotating along 1. The principal axis is 1 here. Okay, in the middle of this curve, what will be? Y is equal to 1 will be here. If we are taking here 2, then now you can see in the middle of this curve 2 is there. It means principal axis is now y is equal to, principal axis y is equal to 2, this one. Okay, this represents the principal axis. In the same way, here we can do for cos and tan. Okay, here we are taking for cos, everything we are making here 0 and 1. Now this is cos. Okay, y is equal to cos x. This is the graph of y equal to cos x. You know, at 0 cos is 1. Okay, at 90 0, 180 minus 1, 270 0, 360 again 1. Okay, here we are taking first of all amplitude 2. Now you can see from principal axis, this red is the actual graph of y is equal to cos x. Okay, the basic function graph. Then this green is the new, in which we are taking 2 as an amplitude. From principal axis to the maximum point, this distance is 2, you can see easily. Okay, or here from principal axis to the minimum point, this distance is also 2. Then here period we are taking here 2. Then 360 divided by 2, as here 2x cos 2x, then cos x has period 360. Divided by 2, 360 by 2 will be 180. Then graph of cos will repeat itself after every 180 degree. From 0 to 180 is same graph. Then again from 180 to 360 is again same graph. Okay. Then after that, the vertical translation. Okay. Vertical translation, suppose we are taking 2 as a principal axis. Here 2 we are taking. Now you can see this y is equal to 2 is at the middle of this curve. Okay. This is as the principal axis. Okay. Before that, this red line is revolving around x-axis. Okay. But now the principal axis is y is equal to 2, not the x-axis. Okay. Y is equal to 2. Here we are taking y equal to 2. That is the vertical translation. Okay. In this way. Now you can see here period is also coming 180 degree, amplitude is 2, and angle we are taking in degree. We can take it in radian also. Okay. At the place of pi 180 there will be pi, at the place of 360 there will be 2 pi. Just these units here will be in radian. Okay, instead of degree. You can see now this I converted into radian. At 360 is 2 pi. Okay, 720 is 4 pi. 0 will be 0. This is the way to draw the graph of different type of trigonometric functions. Now we are going to start exercise 9.4. Question number 1. Question 1 is the following functions are defined for 0 to 360. Here domain is given from 0 to 0 less than or equal to x, x is less than or equal to 360 degree. For each function, write down the amplitude. We need to write here amplitude, period, then coordinates of the maximum and minimum point. Coordinates of maximum and minimum points. These things are required here. First part is y is equal to f of x is equal to here 7 cos x. F of x is equal to 7 cos x. To draw the graph, first of all, we need here the table. Here he's not asking for graph. He's just asking to find these amplitude, period, and coordinates of the maximum and minimum points. As in the topic I told you, f of x or y, we can write a cos bx plus c, the general form of the function. This in the beginning of cos, this a represents the amplitude. This is the amplitude. It means amplitude is 7. After that, this bx, b affects on the period. Period of cos x is equal to 360 degree. If here is cos 2x, then 360 by 2. Cos 3x, then cos 360 divided by 3. Okay, but it was only cos x, then period will be 360 degree. As this given domain is in degree, then we have to write here answer in degree. If it will be from 0 to 2 pi, mean in radian, then our answer should be in radian. After that, what is saying, maximum and minimum point. Maximum and minimum point. You know what will be the maximum point and what is the minimum point. From the this sketch you can understand easily. You know, graph of cos is like this. Graph of cos is like this. This is the maximum point and this is the maximum point and this is the minimum point. Okay, as amplitude is 7, then from principal axis to this point this is 7, and principal axis to this point this is down -7. One thing is clear here, that for this point here, you know, on y-axis x is 0 and y is 7, and for this point, as here one complete revolution period is finishing, then here is 360, then here is 360, then here x coordinate is 360 and y-axis on y-axis is same 7, here will be 7, and this value is coming at the middle from 0 to 360. This is at the middle. At the middle, you know, 180 degree. It means long x-axis 180 and long y-axis is down. Down mean -7. X coordinate is 180 and y coordinate is -7. It means here 2 maximum points and 1 minimum point is here. Okay, maximum points are 0, 7 and 360 degree 7. Then minimum point is 180 degree and -7. This is the answer.